Let us understand how to install database connector to connect to Postgres database and run queries. As we are going to use Python as a programming language, we have to take care of installing Python related libraries. We'll also try to connect to database and submit a query as part of the validation. You can install Postgres Python connector using pip install scopg2 or pip install scopg2-binary. Scopg2-binary will install some additional libraries which will facilitate you to connect to the database from your system. If scopg2 fails, make sure you try installing scopg2-binary. When it comes to connecting to the database, on top of this library, you also need to have information related to host name or IP address on which database is running, the port number using which the database is running, the database name, and also the credentials to connect to the database. On top of these things, you also need to ensure that right permissions are provided on the database to the user to perform required operations. So in this case, whatever user you are trying to use to connect to the database, that user should have all the right permissions. In this case, for CRUD operations, the user need to have select, insert, update, and delete permissions at the least. And this is how a typical database program will run for a mobile or web application. The request will come from the client. The client can be our browser. The request will go to web or app server. In that, we typically install scopg2 or scopg2-binary. And also we need to configure the details to connect to the database running remotely to the web or app server. And the information is nothing but host name, port number, database, username, and password. Without this information, the web or app server, which might be running remotely to the database, it will not be able to connect to the database. If it is a Java-based web application, we use JDBC driver. If it is Python-based application, if it is Postgres database, we have to set up scopg2 driver here for us to connect from web or app server to the database. So in this case, we are not going to develop a web or app server. You can consider our Jupyter itself as a web application, and we are trying to connect to the database here. And hence we have to make sure that scopg2-binary is installed on this Jupyter based environment. If you are using Jupyter, you can actually use this exclamation and then you can say python 3-m pip install scopg2-binary like this, or you can even skip this. Even without this, it should be able to install. If you are using our labs, it is already available and hence it will work without making any changes. If it doesn't work, you can still install for your user and you can take it further. Now the binaries are installed. We should be able to import this by saying import scopg2. So the library is available now. Now to connect to a database, we have to use the connect API which is available on top of scopg2 package which is imported here. Connect will take keyword arguments. There should be host, port, database, user, password, etc. If you try to get the help on connect, you will not be seeing any details with respect to arguments directly. You can see here. It just says DSN equal to none, connection factor equal to none, cursor factor equal to none, and then keyword arguments. As it accepts variable keyword arguments, we can actually pass the information like this: host, port, database, user, password, etc. However, the keywords should match these words, otherwise it might not work. You can also pass the details in the form of a string if you want. When it comes to string, it should be like this. So either you can pass the connectivity information using this approach or this approach. Here I am using the second approach where the host, port, database, user, password are set to these values. So in this case, Postgres is running on localhost on port number 5432. If it is running remotely, you should have IP address or DNS alias on which the database is running, and you have to update this, then only it will work. In my case, the database name is nothing but itversity SMS_DB. This is the username. This is the password. And this will actually validate by connecting to the database and also closing the connection. So it will take care of establishing the connection and closing it immediately. Now I have developed a function called as getConnection, which takes host, port, database, user, password, and it returns the connection. If there is any exception to connect to the database, either when we pass incorrect host name or port number or database name or username or password, the exception is caught here. That's why we have this try and accept block. Now you should be able to run this, and this function will actually return the connection object. We can invoke this function by passing host, port, database, username, and password. Now you can actually invoke the function in this format. So I have set these variables called as host, port, database, user, password, etc. And I'm passing those variables to the parameters that are defined while defining the get connection function here, and then it will actually take care of establishing the connection and also closing the connection. Now if you change the host to something like localhost 1, which is not correct, if you run this, it will throw error. because we are catching the exception. We are just raising the exception, and hence it actually raised the exception. If you want to gracefully handle this and pass a custom message, you can pass the custom message also. For that, you should be familiar with how to deal with exception handling using Python. I'm not getting into those details at this time. As long as all the arguments are correct, where we have a database running on that host and using that port number, as long as the credentials are correct and database name is correct, it will establish the connection to the database and it will return that object for us. And I'm just closing it without running anything. So the get connection function is working as expected. Now, to run queries, we have to create something called as cursor object. This is how you can actually create the cursor object. You have to use the connection object, and then you have to say connection.cursor, which will return the cursor. So this is how the cursor will be created. In this case, I am not running any query using that cursor. It just take care of creating the cursor and closing the connection. Using cursor, we can execute queries using execute function. Cursor exposes a function called as execute. We can pass a valid query as a string, and we should be able to execute the query. To validate, we will be using information schema.tables because the orders table might not be available in SMS, and hence I am going to use something called as information_schema.tables. Information schema is nothing but the schema name. Tables is a view which will contain the table level details that are created either at system level or at the user level. You will see the output and you can understand based on the output in a moment. It is the table provided by Postgres to give the information of the tables and views that are available for us. You might end up seeing some system tables as output. Don't worry too much if you don't understand. Here I am just trying to validate whether we are able to run the queries or not once the connection object is created. If you go to the code, I have defined the variables host, port, database, user, password, etc. Then I have invoked get connection function to create the connection object by passing these arguments. Then I am creating an object called as cursor using cursor function. So cursor will be of type cursor. Then I have defined a string called as query, which have valid query against information schema.tables with a limit 10, so that we can only see first 10 tables. Then we can actually say cursor.execute of query. Then the query will be executed and you should be able to iterate through the results by using for loop like this. So I'm saying for table details in cursor. So already the query is executed and the cursor will be pointing to the results, and you should be able to see the results iterating like this. There are additional APIs which we can leverage to convert the result set off of the cursor into a collection and process further. We will see those details at a later point in time. For now, we are just iterating through the cursor and we are just printing the table details in this case. And then once the results are printed, we are just closing the connection. Let's run this to ensure that the query is executed successfully and the results are printed on the screen because of this print statement. So this is how you can actually get the connection and validate the connection by passing some general system query to ensure that the connectivity to the database is working without any issues. You need to have proper IP address or DNS alias, the port number, the database, username and password, and also the user should have appropriate permissions on the database to ensure that queries run without any issues. As we have validated, now let's get into the details with respect to CRUD operations, where we will go step by step to understand how to insert the data into the table, how to update the data inside the table, how to delete the data from the table, and also how to query the data from the table using some basic filter conditions or where conditions.